Good morning, everyone. Today, we are going to discuss a topic in physics, especially in optics, called as refraction. This is the second phenomena of light that we can see apart from reflection. So, we begin today's session of refraction. All of us would have seen this image of refraction, where if you place a pencil, in this case, or a spoon in a clear glass filled with water, you could see that it is split apart at the interface of air and water. This phenomena is called as refraction. Though the pencil isn't cut in half, it appears to be so. A few examples. If we have straws in a glass of water, this is the image that we would see. It would seem as if the straw which is in water is cut compared to the straw in air. Similar is this image where a beam of light is hitting a cubical piece of glass and changing its direction and coming out. So, dear students, refraction is defined as the bending of light when it travels obliquely from one transparent medium to another. For example, I have two medium here, a rarer medium called as air and a denser medium called as glass. Compared to glass, number of molecules in air is less, hence it is called as a rarer medium. Compared to air, the number of molecules in glass is more, hence it is called as a denser medium. We have a ray that is incident on the interface between air and glass. The dotted line along the incident ray shows the path the ray of light would take in the absence of the interface and the two medium. What we see now is the refracted ray. In order to understand this, we draw the normal which is perpendicular to the interface between air and glass. A normal is always drawn 90 degrees to the surface, hence the word normal. If we have to calculate the angle of incidence, angle of refraction, we calculate it or we measure it with respect to the normal. So a protractor is placed at the normal and then the angle from the normal to the incident ray gives the angle of incidence, and the distance or the angle from the normal to the refracted ray gives the refracted angle or the angle of refraction. Depending on whether the ray of light travels from a rarer medium to a denser medium or a denser medium to a rarer medium, there is a shift in the direction in which it is going to move. For instance, when a light ray travels from a rarer medium to a denser medium, it bends towards the normal. So we have the previous case. So I have a ray which is bending away from its path and towards the normal. So this is when a ray of light is traveling from a rarer medium to a denser medium. Similarly, when a ray of light travels from a denser medium into a rarer medium, it bends away from the normal. In all the cases, we draw the dotted line that represents the path undeviated the ray would take in case it passes in between two mediums, in the absence of any interface between two mediums. Here we see that the refracted ray moves away from the normal. Now this is a common phenomena that we would have seen, that light passes through a glass slab and then is refracted. If we observe carefully, there are two interfaces here. The first interface is with air and glass, and the second interface is with glass and air. Let us now understand this phenomena in a little more detail. Refraction of light through a rectangular glass slab. So we have a rectangular glass slab, and as clearly demarcated, we can see the air-glass and glass-air interface. The ray of light is incident on the air-glass interface. The dotted line gives the path the ray would take in case there was no medium present. As we know, it is moving from a rarer to a denser medium, hence the ray bends towards the normal. Now, the ray moves from glass to air, and as it is going from a denser to a rarer medium, it bends away from the normal. The angle of incidence is taken as the angle in between the normal and the incident ray. The angle of refraction is taken as the angle in between the refracted ray and the normal. We construct or we measure a third angle called as the angle of emergence for the ray that is coming out after refracting twice. It is noticed that the final emergent ray that is there is shifted parallelly when in comparison to the undeviated ray, the path the ray would take when it is not passing through any medium except air. The dotted line in this diagram basically represents the path that the ray would take in case this glass slab was not present. We notice that there is a displacement of the emergent ray on comparison with the incident dotted ray. This displacement is called as lateral shift. That is, the ray is shifted parallelly, hence the word lateral. Let us look at the inferences. So when a ray of light passes through a rectangular glass slab, it gets bent twice at the air-glass interface and at the glass-air interface. This is also known as double refraction. The emergent ray is parallel to the incident ray and is displaced through a distance. This distance is called as lateral displacement. When we speak about double refraction here, it only means that the ray is refracted twice in its motion from air to glass and back to air. Thank you.